Oh, hi, folks. Welcome back to your learning and thank you for showing up. Now, you might be wondering, why is this word vertex showing up in a unit on the quadratic formula? Like, Mr. Jennings, if I have a quadratic like 3x squared minus 6x minus 9, I can understand how the quadratic formula should give me this value, minus 1, and this value, 3. Because that's what the quadratic formula is designed to do, is tell you the roots. How the heck is the quadratic formula going to help me find anything to do with this vertex? Well, let me show you. Here's the quadratic formula for 3x squared minus 6x minus 9. Okay, my a is 3, my b is minus 6, and my c is minus 9. When I work that out, I end up with 6 plus or minus the square root of 144 over 6. The square root of 144 is 12. So 6 plus 12 is 18 over 6, which is 3. And 6 minus 12 is negative 6 over 6, which is negative 1. Great. That's these values here, negative 1 and 3. So quadratic formula for the win. But we can also use a part of the quadratic formula to find the vertex. And let me show you what we're doing here. Notice that this plus or minus business here is plus or minus that square root. That's the part of the quadratic formula. And if I just draw on my Desmos here for a second, that from this point here, hey, why is that not working? Give me a pen. Let's go with black. So from here, oh, it's not working for some reason. Anyway, I don't need to do that. Okay, so we're not going to draw on it for whatever reason. But the middle of that quadratic there, I can either go down, which is go down to here, or go up to there by the plus or minus bit. If we look at the plus or minus bit here, it ended up being 12 over 6, plus or minus 2. But plus or minus from where? Actually, this part of the quadratic formula right here, the negative b over 2a part, actually gives you the axis of symmetry. So if I want to find the axis of symmetry for f of x, that's going to be x equals negative b over 2a. This equation here will give you the axis of symmetry for any quadratic, even ones that don't have real roots. So in this case, negative b over 2a, I take negative 6, so x equals negative 6 all over 2 multiplied by a, which in this case is 3. In this case, I get x is equal to positive 6 over positive 6, and so x is equal to 1. Now that's valuable information that can come out of this negative b over 2a mini formula. It's a mini piece of the quadratic formula that you can use to find the vertex. So here, x is equal to 1 is, well, let's go ahead and look at that in Desmos. If I put in this line here, x equals 1, I'll notice that that is the equation of the axis of symmetry and that it passes through the parabola at its vertex. That's useful information. I now know that the x value of the vertex is 1. All I would need to do, if I didn't have the help of Desmos, is to evaluate what this is equal to when x is equal to 1. I find out what the y value is of the vertex. So let's keep going with that. If I know that f at 1 gives me the vertex, let's evaluate it. F at 1 is equal to 3 times 1 squared minus 6 times 1 minus 9. Okay, 3 times 1 squared is 3. Negative 6 times 1 is negative 6. Negative 9 is negative 9. And that all adds up to negative 12. Okay, so what we found is that the function at the axis of symmetry, that's the line x equals negative 1, is equal to this y value. That tells you the point of the vertex is at 1, negative 12. And that, my friends, is useful information that you can use to graph these quadratics yourself. So 1, negative 12 is that point. And that's how this little piece of the quadratic formula was actually telling you the x value of the vertex. That's the equation of the axis of symmetry, negative b over 2a. Really handy trick. Bye for now, everyone.